In our last lesson, we talked about how angles outside of the first quadrant can still be measured. You can have angles that are bigger than 90 degrees, or even bigger than 180, or even bigger than 360 degrees, and just keep spinning around and around. And we can talk about all those angles, including negative angles. Every single one of those angles in any quadrant has a partner acute angle that it shares a lot of properties with. That partner is called the reference angle. The reference angle, a good definition for it that'll help you make sure you graph it right, is the angle between the terminal side of any other angle and the x-axis. It's important to put this in the definition so that you always remember that the terminal side, the reference angle, goes to the x-axis. So if I have an angle in the second quadrant, the reference angle will be here. Notice that that's an acute angle. Forget about what quadrant it's in, it doesn't really matter. If I were to take out a protractor and measure that angle, it would be between 0 and 90 degrees. If my angle is in the third quadrant, the terminal side lies in the third quadrant, then the reference angle is right here. It's the amount beyond the 180 degree mark, or the pi radian mark. In the fourth quadrant, again, because the reference angle goes to the x-axis, this right here is going to be my reference angle. And although in the first quadrant we don't really talk about reference angles because you don't need a reference angle for most angles in the first quadrant, remember that you could end up with a reference angle, an angle of like 380 degrees would be in the first quadrant. And so we would still need to talk about if it's reference angle there. And so that is that one. And one thing that kind of helps you remember where this angle, these reference angles go, if you kind of think of this as like a little bow tie, that helps you remember where the reference angles are. The reference angles are never out here or up there. Those are never reference angles. So what we can do with this is sketch an angle, and then whether it's in degrees or in radians, we can talk about its reference angle. So with what we learned last class, a 210 degree angle is slightly more than a semicircle. The semicircle would be 180 degrees, which means it's into the third quadrant. And so the reference angle would be how much into the third quadrant are we? Well, that's 30 degrees, so the reference angle is 30 degrees. Seven-fourths pi, or 1 3/4 semicircle. 1 3/4 semicircle, we know that puts us halfway through the fourth quadrant. And so the reference angle in the fourth quadrant, different from the third quadrant, is how much more do we need to finish the circle. In the third quadrant, the reference angle was how much did we go beyond the semicircle. In the fourth quadrant, it's how much more do we need to finish the circle. Well, if we've gone 1 3/4 pi, we need 1/4 pi left. In the second quadrant, because negative 5/4 pi is 1 1/4, or a little bit more than one semicircle backwards. And in the second quadrant, the reference angle is how much more do we need to finish the semicircle if we were going positive. And so that one's pi over 4. And negative 50 degrees, this is going to seem pretty obvious when we're done with it, but it's 50 degrees backwards, which means the reference angle is how much that distance is. Well, if we went 50 degrees backwards, I'm in the wrong quadrant. If we went 50 degrees backwards, well then the amount that we need to go here is still 50 degrees. And then just drawing reference angles by themselves is not all that great. But what we can do with the reference angles is pretty cool. What I want you to think about is, here, I'll draw another triangle here. So I can have a bigger version. If I were to imagine an angle in the second quadrant, don't even care what it is right now, but its reference angle would be right here. Let's say we're talking about the unit circle, so makes life easier. So this distance here is 1. The coordinate right here, remember, that would be the x value is the cosine of my original angle theta, this is theta, and the y value is the sine. Well, just remember that if I were to make a triangle out of this, the sine and cosine of this angle in here, this reference angle, has the same measures as the sine and cosine of the theta that we were trying to graph. And that is a huge, huge, huge deal. The sine, and this goes for cosine and tangent and cosecant and secant and cotangent, the sine of any angle is going to be the same as the sine of its reference angle, except it might be negative. And so we'll talk about that. In this example, in the second quadrant, the cosine is going to be positive. So the sine of my angle is the same as the sine of the reference angle, which I don't have a name for it right now, which I'm sort of regretting, but I'll just call it the sine of that reference angle. Whereas the cosine of my original angle, the obtuse angle between 90 and 180 degrees, is the opposite of the cosine of the reference angle, because the reference angle would have to have a positive cosine because it's an acute angle. But in the second quadrant, the cosine would be negative. So we're going to use that as a guide, and we're going to take it a little bit farther in this example. And we're going to just pick an angle. We're going to go with degrees here so that we can kind of use the special angles, because hopefully everybody remembers those. And we're going to find all 6 trig ratios of this 210 degree angle, which, it's not exactly one of our special angles, but we'll see we already know this because we've learned the sine, cosine, tangent of our special angles. So let's always start by drawing the angle and finding the reference angle. You don't have to draw this little arc in the middle here, but I just want to show that the 210 degrees is here, a little bit more than a semicircle, and its reference angle is how much farther we went here. That is 30 degrees. So the reference angle is 30 degrees. So what I need to think about are the sine of 30 degrees, the cosine of 30 degrees, the tangent of 30 degrees. Hopefully we have those all memorized. The sine is 1/2, the cosine is √3/2, the tangent is √3/3. If you don't have it quite memorized yet, just get used to making that chart where we put the sine, cosine, tangent of our 3 special angles, and then you'll read it off the chart. And then to find the cosecant, the secant, and the cotangent of all of 30 degrees, it's just the reciprocal of all of the sine, cosine, and tangent. So the cosecant of 30 degrees is the reciprocal of 1/2. The secant of 30 degrees is the reciprocal of √3/2. And the cotangent of 30 degrees is the reciprocal of √3/3, which, by the way, I certainly could write it as 3/√3. But think about that for a second. Take the 3, divide it by the square root of 3. Well, the square root of 3 times the square root of 3 is equal to 3. That's what it means to be the square root of 3. So if I take the 3 and divide by the square root of 3, that's the reciprocal of √3/3. Well, that must be equal to the square root of 3. So that's the cotangent of 30 degrees. And now that we know the sine, cosine, tangent, cosecant, secant, and cotangent of our reference angle, we can then identify the sine, cosine, tangent, cosecant, secant, and cotangent of our own angle, the 210 degrees. It's going to be exactly equal to or the opposite of the sine, cosine, tangent, etc. It all depends on which quadrant our angle is in. Well, in the third quadrant, only the tangent is positive, which, by the way, includes its reciprocal cotangent. But the sine will be negative. The cosine will be negative. The tangent is positive. And then, since the cosecant matches up with is the reciprocal of the sine, it has the same sign with a G as the sine with an E of 210 degrees, so it's also negative. The secant is going to have the same sign as the cosine, so that is also negative. And the cotangent is going to have the same sign as the tangent, and so that one will be positive. Now we have all 6 trig ratios of a 210 degree angle. Once you get the hang of it, you start being able to do that really quickly, because you start being able to remember the special angles really quickly, so this part comes fast. And you start being able to remember which quadrant each angle is in, and which ones are positive and negative really quickly. So you start being able to do this very quickly once you get the hang of it.